So having said that, let's move to our first board where we will be talking about layer 2 versus layer 3 interfaces and what is the difference. Okay. So I have divided this picture into two parts so that we can have straightforward comparison between layer 2 and layer 3 interfaces. So on the left hand side, I will be talking mostly layer 2 interfaces, and on the right hand side, I will be talking about layer 3 interfaces, and then we can see them side by side. Okay. So what we have on the left hand side, we have just a switch, right? Very simple topology. This switch is having two access ports, 0/1 and 0/2. The green color ports are the access ports. Maybe these ports are part of maybe VLAN 1 or VLAN 10. Let's say these are part of VLAN 10. Suppose this is part of VLAN 10. This is also part of VLAN 10. If you do not have any VLAN on a switch, you all know that it is going to have only VLAN 1. It is as simple as that, right? But suppose here these two ports are access port of VLAN 10, right? And that is what we need to discuss here. Believe me, on these ports 0/1 and 0/2, these ports do not need any MAC address if switch wants to forward the frames. Really, really interesting, right? It doesn't need to have any MAC address configured on it. But yes, some guys have researched about it that yes, we have seen that these interfaces also have some MAC addresses present on them. But the reason is not that the switch require these MAC address to forward the frame. No, absolutely not. And we can see that. Suppose we have a frame here, right? This frame is having an Ethernet header, which I have drawn in yellow, which is L2. And of course, it is going to have source MAC, destination MAC, type field, and whatever you know about it, right? Then from the top layers, we are getting the IP header also, which is going to contain source IP address and destination IP address and many more fields. And apart from that, we are going to have the data. What is the meaning of data? The data is coming from the higher layers. Maybe it is coming from application layer and maybe it is having TCP data also with it, right? But we are not going deeper into that because you all understand that what is happen when the data come from higher layer to lower layer. We have discussed about it, right? It is as good as saying that we have a big envelope like this one. This envelope is my L2 header, which is going to have source MAC and destination MAC. Inside this, we are going to have a blue envelope, the smaller one, which is going to have your IP. And inside this IP, you can have TCP or whatever the data which is coming from application, right? So if I say you need to go through the content of IP packet, what you need to do if you are seeing this lower figure or diagram, you can say, I will open the yellow envelope and then take out the blue envelope from it. If I do this exercise, the meaning is I am doing the decapsulation. I am just tearing down the outer yellow envelope to get the inner IP packet. What is this outer yellow packet? This is your frame, or basically this is your header, layer 2 header, right? If somebody put this blue envelope again back to the yellow envelope, we call it encapsulation. You all understand why we are doing this, because we need to understand it, right? We are going to use it. With this, we are going to understand what is the difference between a layer 2 interface and the layer 3 interface. It is as simple as that. So what is going to happen? Suppose from anywhere, this frame is on this wire, access port. I'm not sure who has created this. Maybe a host which is connected here has created this frame, and now this frame is ready to move on this green wire. It is as simple as that. What is going to happen when this reaches at 0/1 interface of the switch? You all know switch is configured with the VLAN 10, right? It doesn't mean that this frame is going to have VLAN 10 written somewhere. No, this PC who has generated this frame doesn't know about anything, whatever you have configured on the switch, right? How on earth, how come on earth this PC knows about that what you have configured on your switch? This is the responsibilities of network guys, right? It is sending the usual packet, whatever is generated by the TCP/IP stack of um, this laptop. It is as simple as that, right? When this frame reaches to 0/1, believe me, there is no MAC address here. There is no IP address here. I'm talking about those MAC and IP which we can use in forwarding of this method. But believe me, switch doesn't use any MAC, any IP configured on this 0/1 interface, right? It means that what switch is going to do? Switch is going to see only the L2 header. That is it. He won't be even touching the frame. He won't open this yellow envelope. He won't do any decapsulation. Believe me, it is just check the layer 2 header. It is going to see what is written in the destination MAC field. It will check its CAM table. And if it is fine, the destination MAC address is available on any port, maybe 0/2 port, then it is going to forward this frame over this interface. It is as simple as that. Not at any moment switch is going to check what is the configured MAC address on 0/1 port or 0/2 port, because it doesn't need them to forward the message. It just need what is written in the layer 2 destination MAC. It is going to check that, compare it with the CAM table, and then forward it. It is as simple as that, right? Switches is not doing any decapsulation or encapsulation. Means if this yellow packet will be reached, if this yellow packet reached to 0/1 interface of the switch, this packet is going to be intact. Switch is not going to open it. Switch is not going to open the upper envelope, take it out the IP packet, because it doesn't understand the IP. It is as simple as that. All the interfaces which behaves like this, which forwards the packet or the frame on the basis of only layer 2 destination MAC, they are actually your layer 2 interfaces. So 0/1 interface of the switch, 0/2 interface of the switch is actually your layer 2 interface. It is as simple as that. What about the trunk port? You all know trunk can carry traffic of multiple VLANs. And maybe some traffic is going to this host which is connected over the trunk. And basically this is part of the VLAN, maybe say 10. If that is the case, you can send this frame here also, because VLAN 10 is present here in the trunk also, right? For that, you are again not going to open this envelope. You are not going to put anything into this envelope, right? But yes, you are going to put a tag which says this frame is for VLAN tag, so that whenever it reaches to another switch, that switch comes to know that basically this frame is for VLAN tag, and that is what we use trunk for. It is as simple as that. If you haven't gone through the video, please go through that. We have understood trunk in maybe 15-20 minutes there. But during any, if you consider any movement in the processing of this frame by switch is not going to open the frame. It is not going to open this envelope at all. It is going to read that envelope, but it is not going to open that. If any interface behaves like that, then that interface is going to be your layer 2 interface. It is as simple as that, right? At any moment, if you have any doubt, any question, please raise your hand. Supreet has the question. Supreet, you may ask your
Hey,
question. Please go ahead.
hey Vishnu, thank you. Yeah, so I have a question. So getting a little confused. Now, let's say, for example, I have a machine which is connected to this switch and it is on access port and it has a VLAN 10.
Yeah.
and my other end, the destination is on another switch, and both these switches, the
Hmm.
cross current is on trunk port.
Hmm.
But now let's say, for example, on the trunk port, I have not allowed VLAN 10.
Hmm.
So even though it's a broadcast, the switch will broadcast it, but will the traffic for that VLAN 10 will go on from that port, as I have not allowed on VLAN 10 on that port, trunk ports,
It won't
or
go.
it will,
It
okay,
won't go. Let's see this. Let's see this. Let's try to understand it. But your question is slightly different than whatever we are explaining here. So I would
right, right,
rather
right.
choose that question. I will definitely explain it, but at the end of the class. Is that fine?
Not a problem, Vishnu. Yeah, yeah, no
Perfect.
issues. Yeah,
Perfect. But you are pretty much clear about what we are talking about in terms of layer 2
exactly. Yep, I
processing.
got this layer 2 and layer 3 port interface.
Perfect. So basically, layer 2 interface is any interface which is not going to open your frame, right? Doesn't do any decapsulation, encapsulation, but C is the destination MAC address, and on the basis of it, just forward the frame. It is as simple as that. Doesn't matter access port, trunk port, right? Now, just see the right hand side of the diagram, and believe me, it is going to be very, very interesting. What is happening here? On the right hand side of this diagram, if you see, we now have a router. Router has having 0/1 interface here, 0/2 interface here, maybe, right? And again, somebody has created this frame, right? And do not forget about it that this frame is actually just like a bigger envelope. This is your L2, where you are going to make source MAC, destination MAC, and then we have smaller envelope, which is your IP, right? And we all know now for sure that switches, if these are the layer 2 switches, they are not going to open the frame. They are not going to open this yellow envelope to find the blue one. Believe me, router has different working altogether. And that is where L3 is going to come into picture, right? This 0/2 interface is now having the MAC address, which is AAA, and it is also having the gateway or the IP address. Very, very interesting. If I write gateway, you can say it's just the IP address. That is it. On the contrary, if we have seen the left hand side, the layer 2 port doesn't have any MAC address and the IP address for sure. What is the purpose of having MAC address on layer 3 interface? So by the way, we are calling this as a layer 3 interface. Why? I'll let you know. But this frame, when it reaches to 0/2 interface, right, router will behave totally differently than a switch. What router is going to do here? Router will be checking this layer 2 header. It is going to have source MAC address and destination MAC address, right? It is going to check what is the destination MAC address. If destination MAC address is equal to its 0/2 port MAC address, right, which is the port on which this frame is received at the first place, right? So there can be only two ways or two possibilities. The destination MAC address can be equal to 0/2 port MAC address, or the destination MAC address of this frame is not equal to 0/2 port of the MAC address, right? MAC address of the port, right? If the destination MAC address of the frame, and believe me, this router, the first thing it does, it checks what is the destination MAC address. It is going to compare it with the MAC address configured on the 0/2 interface. And if those are not equal, router is not going to entertain this message. It is going to say, I am discarding this message. This is not for me. But on the contrary, what would have switch done? You all know switch is not going to check, not going to compare the destination MAC address or with the MAC address configured on the port, because port is not going to have any MAC address here in the case of switch. Switch just forward on the basis of CAM. I am again comparing both of them, right? The first step is the router is going to compare the destination MAC address with its own MAC address configured on the interface on which this frame is received. If it is not equal, router is going to say discard. This is not for me. But if it is equal, then router do router does an interesting thing, because now router understand that this envelope is for me. Why? Because destination MAC address is AAA, and AAA is configured on my interface 0/2. If that is the case, this router has the complete freedom of opening this envelope, right? MAC address says that whether this message is for you or not, whether this yellow envelope is for you or not, and router is absolutely sure now that yes, it is for me. Why? Because the destination MAC address matching my interface MAC address. As simple as that. If that is the case, router does one interesting thing. It is going to open this envelope and tear it down, right? What is the meaning? You open this envelope, envelope is of no use, you are going to send this or throw this envelope into the dustbin, right? What is important for router is, this IP packet, right? And that is what router does. When this frame reaches to the router, and when router is so sure about it that it is for me, by comparing this MAC address, it is going to remove this L2 header. L2 header job is done. Now what router will see? Router will see only the IP packet, right? IP packet is going to have source IP and destination IP. And for that, router has the routing table. You should understand routing by now. If you haven't, please have a look at my routing course. So in this routing table, router is going to say that if destination IP is this one, then go to 0/1 interface. Maybe whatever, right? Maybe destination IP is 192.168.10.20. And for that, you need to go out with 0/1 interface, as simple as that. And at 0/1 interface, you are going to find another router, which is router 2, which is maybe right here, right? And it might be having address 1.1.1.1. So basically your packet wants to reach to 192.168.10.20, but this router is saying to reach there, you need to go first to router 2, and router 2 will help you moving you, or router will help you to get to 192.168.10.20. It is as good as saying that if you want to go from Delhi to Bangalore on a road trip, then maybe in the middle you will find Jaipur, you will find Rajasthan, right? Or Madhya Pradesh or whatever, right? The packet wants to reach exactly to Bangalore, but it has to go from here, then from here, and then eventually to here, right? You all know about it. And for that, this router is again going to do one interesting thing, because it now understand with this routing table that if it needs to send this packet towards the destination, first thing first, it needs to send it over this green wire. This green wire is again Ethernet. And if it wants to send this packet, IP packet on this Ethernet, it again have to create the frame. It means that it again needs to put the source MAC address and destination MAC address. Source MAC address is going to be BBB, and destination MAC address is going to be the address of this router 1.1.1.1, which is maybe say CCC. It is going to be like this. This is the source MAC. This is the destination MAC. What just router did? Router again took this blue envelope and again put back into the yellow envelope, but this time the content of yellow envelopes are different, right? Content of yellow envelope are, the source MAC address is the 0/1 interface, which is the outgoing interface for this packet, and the destination MAC address is the routers, right? The next hop router. It is as simple as that. So what this layer 3 interface is doing, this layer 3 interface, which is having MAC address and IP address, it carrying a frame, it is going to decapsulate the frame. So when the packet comes to router's interface, it is going to decapsulate it. The meaning is it is going to take that blue IP packet out from the yellow packet, right? Now the IP packets contain source MAC and source IP and destination IP. It will do routing on the basis of that, and then again put that blue envelope into the yellow envelope, but this time the yellow envelope contents are going to be different, right?